Hi guys, welcome back. For today, we will be having the introduction to the Black-Scholes model, an option pricing model. Before we proceed to the topic, we should first have a short review on what an option is. An option is a security that grants the holder the right to buy or sell an asset at a predetermined price within a specified period of time. This lecture is about the valuation of options. To be specific, we will be dealing with call options. A call option is an option to buy rather than to sell. So the issue is, what is the value of an option? That is, how much are we willing to pay for an option? To answer that question, let us go back to the concept of valuation. The value of an asset is the present value of future cash flows it is expected to generate. Again, the value of an asset is the present value of the future cash flows it is expected to generate. In order to visualize the concept of valuation, let us refer to the following diagram. We use this diagram in bond valuation, stock valuation, as well as arriving at the value of the project in capital budgeting. Most option pricing models would rely on what we call the riskless hedge. And this includes the Black-Scholes model. To understand a riskless hedge, imagine a portfolio where the investor buys a stock and at the same time sells a call option on that stock. Take note that as a seller or writer of the call option, the investor here is at the mercy of the buyer or holder of that option as to whether there would be a transaction. Now, it is to be pointed out that we are looking things from the perspective of the seller or writer of the option. Why is this a riskless hedge? Well, if we are going to buy a stock and want to sell it in some future time, what we can do is to sell a call option to guarantee that it will be sold. If we're going to buy that stock and sell an option on that stock, sell a call option on that stock, then basically, there are only two things that can happen. It is either that at the end of the period, by the time we're going to sell the stock price would be higher than the strike price. If that is the case, then the buyer of the option will definitely exercise such an option, considering there will be a gain. If the stock price becomes lower than the strike price at the time we're going to sell the option, well, the buyer would definitely buy the stock at the open market without using the call option. In either case, we would end up in a situation where we would be able to sell the stock. Now, the question is, how much are we going to sell the option in such a way that we will end up in a riskless position? The same outcome no matter what. Well, because this is a riskless hedge, we are expected to earn the risk-free rate of return. In this simplified example, we are going to assume that there are only two possible scenarios. That's why we call this the binomial model. Refer to the following sample case. The common stocks of ABC Incorporated currently sells for 43 pesos. There is a call option on this stock with an exercise or strike price of 40 pesos. At the end of year 1, there is a 50% chance the price will be 35 pesos and another 50% chance that it will be 55 pesos. The risk-free rate of return is 4%. What is the value of the option? We can actually construct a riskless hedge here. Step 1, set the range. Note that there are only two possible scenarios. This is a simplified assumption of the binomial model. The stock price at the end can be 35 pesos. Considering the strike price is 40 pesos, when the holder or buyer of the option encounters this situation, he or she will not exercise the option and therefore buy it at 35 pesos. There is no exercise value. If the stock price at the end will happen to become 55 pesos at a strike price of 40 pesos, the buyer or holder of the option will definitely exercise this. By doing so, he or she will buy at 40 instead of the stock price at 55 in the outside market. So we have a range of 20 pesos difference for the stock price at the end of the period, that's 1 year. But for our option, the exercise value then will either be 0 or 15, having a range of only 15 pesos. Step 2, let's equalize the payoff. We want to arrive at a situation where the difference in the outcome will have the same range. As such, we are going to adjust the number of stocks per option sold. A 20 pesos payoff range for the stock price and a 15 peso range for the exercise value of the option at the end will be equalized by multiplying such by 15 divided by 20 or 0.75. By doing so, we will have the following stock value at the end of the period. So we would have 35 times 0.75 and 55 times 0.75. The stock price of the fraction of that stock, again that's 0.75, would be 26.25 or 41.25 respectively. Such being the case, we were able to equalize the payoff of both the stock price and the option. The stock price, or more accurately, 0.75 of the stock price, has a range of payoffs of 15 pesos. Same with the payoff of the exercise values. Step 3 is to create a riskless hedge portfolio. So, the riskless portfolio will consist of the following. We are going to buy 0.75 of the stock and sell one whole call option for each 0.75 of the stock. This may be unrealistic, but we can make it realistic by buying, for example, 75 common stocks and then sell 100 call options for that common stock. Now, if we're going to analyze the situation, the ending stock value of the 0.75 stock will be 26.25 if the stock price is 35. If such is the case, remember that the option value would be 0. So the value of the portfolio is 26.25 in total. Second possible outcome, the stock price is 55. Considering that there is only 0.75 of the stock, that would translate to 41.25. Under this scenario, however, the option value at the end will be 15. That is the exercise value. Considering that there is a 15 pesos value for the holder of the option, this would be negative 15 considering we are the seller of the option. 41.25 minus 15, the portfolio value would be 26.25 as well. As you have noticed, no matter what happens, because we bought 0.75 of one stock and sold one whole call option for that stock, we would end up with the same value of the portfolio. Our riskless hedge will have a value of 26.25 a year from now, the period of the option. Considering we're arriving at the value of the call option, we will start with the value of the portfolio. The value of the portfolio can be arrived at by taking the present value of the future cash flows. If it is 26.25 a year from now, we're going to take the present value using the risk-free rate of 4%. 26.25 divided by 1.04, the value of the portfolio would be 25.24. Now, remember that the portfolio has one option and 0.75 of a share. So we can extract the value of the call option by deducting the value of the share from this value of the portfolio. So we would have the value of 0.75 of the stock now. That would be 43 pesos. This is given in the case, times 0.75. We would have a stock value for that 0.75 share, 32.25. So, if the value of 0.75 of the share now is 32.25, we can deduct this from the value of the portfolio, ending up with the value of the option now at negative 7.01. Again, we are looking things from the perspective of the seller of the option. That is the reason why we have a negative figure for the value of the option. But of course, from the point of view of the buyer, this would be a positive value, 7.01 in our sample case. Now, why did I discuss the binomial model as an introduction to the Black-Scholes model? Because the very fundamental principles are the same. In this binomial model, we assume two possible scenarios. But in reality, there are a range of possible scenarios. To be specific, there are actually infinite possible scenarios. The stock price can be 55, 54.99, 54.98, 54.90.
A few moments later.
35. That is the reason why the binomial model is insufficient. This is where the Black-Scholes model comes in. According to the Black-Scholes model, this is the formula in arriving at the value of a call option. At first glance, this might appear too complicated to understand, but the very basic principles were actually discussed already. The value of the call option is the sum of the value of the stock, adjusted in this formula, and the value of the portfolio. Note that the signs were inverted this time because we are looking things in this model from the point of view of the buyer of the call option. In the next video, we are going to dissect the formula and apply it in possible real-life scenarios. So that would be all for this video. Like, share, and subscribe.